Hi everyone, this is Mrs. J, and today we're going to be learning about the sums of finite and infinite series. So I have a quick warm-up for you guys, so please pause the video and give these a try, and when you're ready to check, hit play. Alright, so go ahead and check your work here. For the first one, this is neither arithmetic nor geometric because there's no common difference and there's no common ratio. For part B, it's an arithmetic sequence because there is a common difference of -10, meaning we add -10 each time to get to the next term. And part C is geometric because there is a common ratio of 1/2, meaning we multiply by 1/2 to get to the next term. So today we're going to be learning some formulas that we can use to help us find sums of some finite arithmetic sequences or series, some finite geometric series, and even some infinite geometric series. So we're going to start with how to find the sum of a finite arithmetic series. So in the past, when we've done this, we had to expand out the terms by hand and then just add them up, which is fine. But if you're finding the sum of a series with 100 terms or a ton of terms, that could take a long time to do by hand. So luckily, there's a formula. So if you have a finite arithmetic series, finite meaning it ends, it is not going on forever, we can find the sum using this formula. So the sum of the first n terms of a finite arithmetic series is n over 2, where n is the number of terms, times a sub 1, where a sub 1 is the first term, plus a sub n, where a sub n is the last term of the series. Okay, so we're going to be using this formula to find the sum of the first n terms. All right, let's have a look at example 1 together. So this says find the sum of the first 15 terms of the arithmetic sequence a sub n equals -3 times n plus 4. So again, here's the formula we're going to be using. So the sum of the first n terms is n over 2 times a sub 1 plus a sub n. So we're finding the sum of the first 15 terms. So that means that n is 15. But we still need to find a sub 1 and a sub n. So we can do that using our rule over here. So let's figure out what's the first term. So we substitute n with 1. So -3 times 1 plus 4. So a sub 1 is 1. And let's find our last term. So a sub n, which in this case should be a sub 15. So we're going to find the 15th term. So we do -3 times 15 plus 4. So our 15th term, which is the last term of our series, is -41. Okay, so now let's substitute what we know into our formula. So the sum of the first 15 terms is going to be 15 divided by 2 times 1 plus -41. Let's always remember to do what's inside our parentheses first. So 1 plus -41 is -40. And then from here, we can do -40 divided by 2 times 15. And this should give us a sum of -300. So the sum of the first 15 terms is -300. So you can see that this is definitely faster than having to list out what the first 15 terms are and then adding them up. So this formula can be really useful. Okay, let's try another example together. So here they want us to find the sum of this series. So again, we're going to be using that same formula. And let's see what kind of information we can get from what we were given. So all I see here, well, one thing we can note is that it is an arithmetic series because there's that common difference. We're adding 2 to get to the next term. And we do see that, well, right now all we know just by looking at it is that the first term is 2. But we also need to figure out Oh, we also know that the last term, so a sub n, is 32. That's our last term, but we need to know what n is. We need to know what place in line is 32. So to do this, we can actually make our formula, our explicit rule. So remember, for this, we do a sub n equals a sub 1, which is 2, plus n minus 1 times our common difference, which is 2. And then we can say a sub n equals 2 plus 2n minus 2. And that means that a sub n is simply 2n. So this is the sequence, or this is the rule that would define this sequence. So again, we know that the last term is 32, but what's the n value here? N equals what? What place in line is it? So we can actually substitute 32 for a sub n, because that's the actual term. And that will help us figure out the n value, what place in line. So n is 16. So this is actually the 16th term. So again, we could just kind of continue the pattern and then until we get to 32 and then count, but I think it's actually a little easier to make the explicit rule, and then we substitute the term with a sub n to figure out its relative position in line. So again, n equals 16. So we're finding the sum of the first 16 terms. So the sum of the first 16 terms would be 16 divided by 2 times 2 plus 32. So 16 divided by 2, which is 8, times 34. So the sum of the first 16 terms is 272. So again, you can see that this formula can be a real time saver and is very useful. All right, we're going to try one last example together. So here we have a series written in sigma notation. So again, they're asking us to find the sum of the 4th through 12th terms. So now here's the tricky thing about this problem. For our formula, it's the sum of the first however many terms. So for this one, they don't want us to actually include the first 3 terms. So we're actually going to find the sum of the first 12 terms. So we're going to find the total sum, but then we're going to take away the ones we don't want. So we actually don't want the first 3 terms. So we're going to take away the sum of the first 3 terms. And that should leave us with the 4th through 12th terms. So we do need to find 2 separate sums here, and then we're going to subtract. But let's see if we can find the information we need. So let's start by finding the sum of the first 12 terms. So we need to know a sub 1. So a sub 1 we can find by substituting it into our explicit rule. So our first term is 5 times 1 minus 3, which is 2. So again, here's how we find the sum of the first 12 terms. A sub 1 is 2. Then we need to find a sub 12. So a sub 12, again, let's plug it in. 5 times 12 minus 3. So the 12th term is 57. And again, here n is 12 because it's the sum of the first 12 terms. So let's do this. So sum of the first 12 terms is n over 2 times a sub 1 plus a sub n. And now we can simplify. So the sum of the first 12 terms is 6 times 59. And that gives us 354. So again, that's the sum of the first 12 terms, but they only want the 4th through 12th. So now we need to find the sum of the first 3 terms so we can subtract. So let's do that over here, the sum of the first 3 terms. So we already know that a sub 1 is 2. We can quickly find a sub 3 by plugging it in here. So that will give us 12. And again, n is 3. So let's find the sum of the first 3 terms. So we do 3 over 2 times 2 plus 12. So here the sum of the first 3 terms will be 3 over 2 times 14. So for this, we can do 14 divided by 2, which is 7, times 3, which is 21. So now that we know the sum of the first 12 terms and then the sum of the first 3 terms, we can do the initial little formula we came up with here. The sum of the first 12 minus the sum of the first 3. So 354 minus 21. And that gives us a sum of 333. So again, just remember our formula is for the sum of the first however many terms. So if you are not starting at the first term, we can still use the formulas, but you can find the total sum and then take away the ones that you don't want. So again, we wanted to start at the 4th term, so we took away the sum of the first 3. Alright, so this time I'm going to ask you to pause the video and give these two a try, and we'll check your answers in just a few seconds. Alright, so go ahead and check your work. For the first one, to find the sum of the first 10 terms, we know n is 10. You can find a sub 1, which is 0, and the 10th term, a sub 10, is 18. So plug it into your formula, and we should get 90. And for the second one, they only want the sum of the 3rd through 9th term. So we can use our formula still, but we have to find the sum of all 9, and then we have to subtract the sum of the first 2. Because again, they want us to start at the 3rd term. So here's how you find the sum of the first 9 terms. And here's how you find the sum of the first 2 terms. And so then you do negative 180 minus negative 12. And you should get negative 168. So definitely a little bit trickier when you're not starting with the first term. Alright, so now that we know how to find the sum of a finite arithmetic series, we can find the sum of a finite geometric series. So there's a formula for this as well. The formula is right here. So it's s sub n, so the sum of the first n terms, equals a sub 1 times 1 minus r to the power of n all over 1 minus r. So again, a sub 1 is that first term, r is our common ratio, and n is the number of terms. So again, this is the sum of the first n terms. So this formula is assuming that we're starting with the first term. All right, let's give these two a try together. So let's start with this first series. So first, let's check to make sure it is actually geometric. So from the first to the second term, we multiply by 3 and then multiply by 3, so it does have a common ratio. So they want us to find this sum all the way up until when n equals 10. So they would like us to find the sum of the first 10 terms. So again, here's our formula. So a sub 1 times 1 minus r to the power of n all over 1 minus r. So we can see from the series that a sub 1 is 1/3. You see that right here, our first term. We've already found that common ratio of 3, and again, they want us to find the sum of the first n, the first 10 terms. So here we have everything we need to use our formula. So the sum of the first 10 terms is 1/3 times 1 minus 3 to the power of 10 all over 1 minus 3. So we can start by doing what's inside the parentheses. You can do 1 minus 3 to the power of 10 in the numerator, and then we can divide that by negative 2, which is the denominator, and we get 29,524. So we could divide that by 3 and get a decimal, or we can just keep it as a fraction, which I think is better for these type of problems. So it's just 29,524 over 3. All right, let's look at this next one. So again, here we have a summation in sigma notation. So if they're going from 1 to 7, they would like us to find the sum of the first 7 terms. And I know that this is geometric based on how this explicit rule looks. So to find the first term, a sub 1, we can take our rule and we can substitute I with 1. So 3 times 2 to the power of 1 minus 1. Remember, anything to the power of 0 is 1. 1 times 3 is 3. So our first term is 3. We can see from the explicit rule that our common ratio is 2. We could have also done that to find the first term. So remember, it's always a sub 1 times r to the power of n minus 1, or it's typically that. Sometimes you'll just see n here, it just depends, but we can see that our common ratio is 2, and that we know that they're asking us to find the sum of the first 7 terms. So n is 7. So now it's just plugging it to the formula. So sum of the first 7 terms equals a sub 1, which is 3 times 1 minus 2 to the power of 7 over 1 minus 2. So again, you can start with what's inside the parentheses. We can do 1 minus 2 to the power of 7, which is negative 127, and then you can divide that by negative 1. So it becomes positive 127, and then you just multiply that by 3. So the sum of the first 7 terms is 381. Alright, so go ahead and pause the video and give these two a try on your own, and we will check your answers in just a few seconds. Alright, so go ahead and check your work here. For the first one, this is geometric, so our first term is negative 2, our common ratio is 2, and they want us to find the sum of the first 6 terms. So just substitute your values and simplify, and you should get negative 126. For part B, again, the first term is 2. The common ratio is 1/2. They want us to find the sum of the first 8 terms. So you can plug it in. Here it's a little bit trickier to simplify. It's a little more work with the fractions. But if you do 1 minus 1/2 to the power of 8, it's 255 over 256. And the denominator, you're left with 1/2. So you can multiply by the reciprocal, and then it's just a matter of simplifying. So you get 255 over 64 as your final sum. All right, so the last thing we're going to talk about in this lesson is how to find the sum of an infinite geometric series. So it is actually possible to sometimes find the sum of an infinite geometric series, meaning a geometric series that goes on forever, but it has to be under the right circumstances. So 1, it definitely has to be a geometric, and 2, this will only work if your common ratio, which is r, the absolute value of your common ratio is less than 1, meaning another way of thinking about it is that your common ratio must be between -1 and +1. Now, if your common ratio is not between -1 and +1, it is not possible to find the infinite geometric sum or series. So sometimes, your answer will just be not possible or does not exist. However, again, if the circumstances are right, you can find an infinite geometric sum using this formula. So the formula is actually really easy to use. It's just a sub 1 over 1 minus r. So it's the first term over 1 minus r, which is the common ratio. Okay, so just remember, it's not always possible to find this sum, but sometimes it is. So we have the formula to help us. All right, let's give these two a try together. So here you can see that we have an infinite sum because we have 1 plus 3 plus 9 plus ... There's no end to it, so we know it's infinite. So the next thing we need to do is see what's our common ratio. So here I can see we're doing times 3 times 3. So our common ratio is 3. Now remember, this only works, we're only able to find an infinite sum if the absolute value of r is less than 1. So here, 3 is not less than 1. So here's a case where it is just simply not possible. Okay, so don't try to force it if the R value is not correct or within the right range. It's just not possible to find that infinite sum. Now let's look at part B. So here, let's check to see what our common ratio is. We're times 1/2 times 1/2. So we can see that our common ratio is 1/2. And the absolute value of 1/2 is less than 1. So this actually works. We can find this infinite sum. So we're going to use that formula. Remember, S equals A sub 1 over 1 minus R. So we can see that our first term, A sub 1, is 1. So let's plug it in. So that infinite sum is 1 over 1 minus 1/2. And let's keep these as fractions and simplify. So in the denominator, we have 1/2. And if we multiply by the reciprocal, right, we're doing 1 times 2. So 1 divided by 1/2 is actually 2. So if you continued this series on forever and you found the sum, it would actually come so close to 2 that we actually just call the infinite sum 2. All right, so here's the last two for today's video. So please pause the video and give it a try on your own. And when you're ready to check your answers, then you can hit play. All right, so let's check our work. So in the first example here, our common ratio is 1/4. And since the absolute value of 1/4 is less than 1, this situation applies for an infinite sum. So our first term is -12, our R value is 1/4. Plug it into your formula. So this gives us 12 divided by 3/4. So remember, when you divide by a fraction, you're really multiplying it by the reciprocal. So we're actually doing 12 times 4 over 3, which is 16. And to simplify this, you can do 12 times 4, then divide it by 3, or you can do 12 divided by 3 and then multiply that by 4. Either way, you'll end up with 16. For part B, our common ratio is 5, so that is not within the range of possible R values. So for part B, we just say not possible. All right, so that is all for today's video. Thank you guys for watching.